So our last topic for this unit is something called inequalities, which really means like not equal to. So when we have equations that have these symbols in them, that's when we know we have what's called an inequality. And what it really means is that our answer can be a whole range of answers instead of just one number. So we're going to look at how to find those and how to understand those in this lesson. So the first symbol that we see here is pointing to the left. And so if I was to use a symbol like that, I might write 3 is less than 5. If I have the symbol pointing the opposite way, then that means greater than when it's pointing to the right. So then I would have to write 5 is greater than 3, just bigger than, right? And so for the next symbol, we have a combination of an equals and a less than. And so we could have, in that case, x is less than or equal to 3. And that means that we could have 3 or 2 or 1 or 0 or -1 and just keep going to the left for all the values that x can be. It can be a whole bunch of different values, but nothing bigger than 3. And the same with greater than or equals to. If I started with something like x is greater than or equal to 5, then it means that the lowest number that x could be is 5, or it could be 6 or 7 or all the way up to infinity. Any value that's bigger than or equal to 5 will work for the value of x. So when we're solving inequalities, it's really helpful for us to use a number line or draw a graph to show all the different values that x can be. In the first case, we're looking at an empty circle starting at -18. So we know that -18 is important. Let's write that down. And we can see that the arrow is pointing to the left, so we know that we need this symbol that also points to the left. And then we can put an x in there. And the reason that we don't have x less than or equal to 18 is that that circle at -18 is empty. If it's colored in, it means equals and less than. If it's open like that, it means just less than. So in the next slide, we've got a solid circle at -18, and it's still pointing to the left. So -18 is our important starting number. Let's write that down. And we can see that everything's pointing to the left, so we'll have our symbol pointing that way as well. But when we decide if we should also have the equals with a less than or greater than, we look to see if the circle is colored in at -18. If it is, then we also put the equals there, and then we put the x on the left like that. So for the next one, we're starting at -18, but it's going the other way, isn't it? It's going to the right. So -18 is our important starting point. Our symbol is going this way this time because it's going to the right. And then we have to decide whether we put an equals or not with that greater than sign. And in this case, our circle is empty, so we don't need an equal sign, just a greater than. And then in the last example, again, -18 is important. Everything's going to the right, so I'm going to include my greater than symbol. I'm going to put x here, and then I'm going to decide if I need a negative or not, or an equals or not. And I do need an equals here because -18 is colored in with that circle. So here's another example of a number line showing an inequality. And so in this case, everything starts at 5. So 5 is important. Everything is going to the right, so we're going to put that symbol. We're going to put the x here, and then we're going to decide do we need it to be greater than and equal, or just greater than. If the circle's empty, it's just be highest. So that means that we're going to also include the equals for the 80. So we're looking for an expression that says x is greater than or equal to 80 degrees. Here it is down at the bottom here. X is greater than or equal to 80 degrees. This one's talking about Mount Everest, and it said the elevation or the height of Mount Everest is currently no more than 29,029 feet. So that's the highest it possibly could be. And so that means it could be that, or it could be lower than that. And so our arrow is going to point to the left for that. So we're going to use a less than symbol. And so we're going to have x here. We're going to have 29,029 on the right side. And are we going to put the equal sign in? Yes or no? So can it be equal to 29,029 feet? Yes, it can, but no more than that. So that's the highest point possible. And then all the lower points are also possible. So when we look for that answer in our choices, here it is. When it comes to solving inequalities, we're not really going to learn anything new for these types of equations or inequations. We are going to use what we already know. What we're going to do is just pretend that this equation is an equals. We're going to switch it out at the end, but because we already know how to solve equations with equals in them, we're going to use those skills to solve these equations as well. So we know that if we have 4x minus 1 equals 7, if I add 1 to both sides, then this makes that 0, so I have just 4x. And on the right side, I would now have 8. And now if I divide both sides by 4, that's going to cross out my 4's on the left, so I have x equals, and 8 divided by 4 is 2. So the only extra step I have to do if it's an inequality and not an equality is write, therefore, x is always less than 2. And sometimes they might ask us to put it on a number line to show exactly what's happening. So in that case, I would draw an open circle above 2 because there's no equals in this equation. And then I would draw an arrow pointing to the left because all the values smaller than 2 can work to solve this inequality. Same thing here, we're just going to do a little bit more practice. And so I'm going to rewrite this as an equation. I'm going to put an equals in place of my less than or equal to sign. I'm going to add 8 to both sides. This is fun because we get some more practice with linear equations. So 8 and 8 make 0, negative 8 and 8. And I've got 9x left on this side, and on the other side I have 36. Now if I divide both sides by 9, the 9's will cross out on the left, and I have just x, and 36 divided by 9 is 4. So now I'm going to go back for my last step, and I'm going to say, therefore, x is less than or equal to 4, because that's the symbol we started with. Okay, this one's simple. We're just going to do 5 minus 5, and that means we do the same thing on the other side of the equation. So I'm going to have 0 there. X equals 1 minus 5, so that's negative 4. And now I'm going to change my sign back to what the question said, which was greater than. So x is greater than 4. I hope you're finding these really straightforward. Just like when we did the simple linear equations, it's all the same rules. This one's just a little bit more challenging because we have x's on both sides of the equation, but we know how to handle this just one step at a time. And so if we rewrite this equation as 5x minus 12 equals 3x minus 4, then the first thing I want to do is move that 12 by adding 12 to both sides. So now I have 5x equals 3x, and negative 4 plus 12, we have 12 positives and 4 negatives. The positives win by 8. The last step is to move that 3x, so I'm going to subtract away that 3x from the right side, and I also have to do it on the left. So 5x minus 3x leaves me with 2x's. And on the right side, I just have 8. If I divide both sides by 2, I now have x equals 4. So our answer to this equation or inequation is x is less than or equal to 4. That's it. As long as I keep my numbers at 4 or less, then the left-hand side will always be lower than the right-hand side. If the number is 4 exactly, then they'll be equal. So on your notes sheet, this should be our final box on our notes sheet because we're going to get ready now to do the practice test on this unit. You want to write yourself a little note about what each of those symbols means. Write yourself a note about changing the greater than or less than sign to an equals if you're being asked to solve the equation. Write yourself a note about an empty circle versus a solid circle on the number line so that you'll remember all of those things when you're working on your test.